In the previous session, we discussed about searching algorithm 1. So today we are going to see searching algorithm 2. Before that, a short recap about what we have seen so far. So this algorithm is the last thing that we have seen. This is nothing but a search algorithm 1, some basic algorithm like for to solve a problem. So we are about to take a topic which is a problem solving. There we went into searching to solve the problem. So in searching we saw this first algorithm. So what this algorithm initially is doing, like it is taking a open list, and from the open list it is picking any node, and it is testing for the goal. If the goal is present, then we are coming out of this loop, or else like we are going to remove this node. After removing this node, I'm going to append the neighboring nodes of say n into the open list again. So I have explained this in briefly in the previous session. You can look into that. It is exactly the graph search. Like the difference is like we have given the only the initial node of a graph, say yes, and from there we deriving a, b, c. That is what we saw in this session. So the diagram which is in the middle is like the topic that we are going to criticize this algorithm. That see that green color ball, it is a kind of maze here, and the green is going to move around the maze, and we can see that it is going in a direction which is already been discovered. So it continues in the form of a looping structure. So this type of algorithm that we have seen so far, the search algorithm one, it goes into a loop because like we didn't formulate any procedure that we should not visit the same node again in that way. So uh, we are going to derive a new algorithm in such a way that this problem, like we should not visit the node which has been visited already, will be solved. So this is a strategy that we are going to see in this algorithm. So we'll go to the straight in the next point. So here, as I told you already, the problem that has been faced in the search algorithm, one is a looping form, like the node which has been visited already has a chance to visit again. How we can solve it is like we are going to solve this algorithm by storing the visited node into a separate list, and we are going to make a comparison. To brief this in detail, I can tell like you have a cube in your Rubik cube in your hand. I think this we discussed in the first session. So there may be a chance for us to rotate this Rubik cube and come into a present state. See, we may be in a first state and we'll be rotating this Rubik cube say 10 times or 12 times. There may be a chance for us to come back to the original state, that is come back to the original state. So what will be the original state? Like it will be the state that is given to our hand, that is given in our hand. So there may be chance for us to take back to the original state. So what our algorithm that we are devising now is going to do is like it will prevent us from going back to the a state which has been visited already. So by this, like we can prevent some looping within the search. So how we can do this thing is like this is an algorithm which is on the left hand side is an algorithm, the first algorithm that you have designed. We done it step by step. We know how this algorithm is formulated. If you have doubt in this, you can go and watch the first session. So what this is like, after the first step open, which is adding this yes node, we are going to put into this closed list. Like we are going to create a new list which is called as closed, which is going to be initialized as null, and we are going to pick any node from the open list as we done in the first search. And then what we are going to do is we are going to add the n into the closed list. So why we are adding that? Because it is mean to say that this node has been visited in that way. So we are adding two steps that has been introduced. One is we are introducing closed as a list. We have created a new list which is closed, and then we have added n to the closed list. And again the goal test, same procedure that we have done in the same previous thing. The last one is like we can where like in the open list we are going to make some change, which is like open is going to be open union mogen of n, which is there, but we are going to delete some nodes here from the mogen, which is going to be open union of closed. What this means is like we are going to combine this open and closed list, and we are going to remove that from the mogen function. This makes the thing that I'm going to combine some nodes into open list which should not be there in the closed list. So that is the step that we have done here. That is, we are deleting the node which is there in closed list as well as in open list. I am combining that and I am taking it into the mogen function, and I am going to delete those node and I am going to make a union there. So it's nothing but open will be there already, but some nodes which is added into the closed list, that is while we are generating the neighboring node at the initial step, we are adding that into the closed list. So we are removing that closed list also here in the open list. So the open will contain only the fresh element. The node which has been visited already will be taken away. So this is our algorithm. So exact algorithm that is to be followed, like this is the exact algorithm that we discussed now. So I've created an open list and a closed list, and I'm going to pick a node from that say open list, and I'm going to add that n into the closed list. So next I'm going to test whether the n has reached the goal or not, or else I'm going to make this thing that we have discussed now. Again, this algorithm that we are devised now will have some problems. As I told you already in the first session itself, that the algorithm, the evaluation of the algorithm is dependent upon some issues. That we will face some issue and we'll be going for the next algorithm. Similarly, these are some basic algorithm like what we have seen so far, like search algorithm 1, search algorithm 2. These are some basic algorithm where we faced some issues. For example, the search algorithm 1, we looked into an issue which is like there will be a looping among the paths, that is looping among these nodes. So that we went into the searching algorithm 2. In searching algorithm 2, we devised a solution for this looping formation. Similarly, this algorithm is having some issues. We'll discuss in detail in the next session, and in the next session we'll see about DFS BFS, which is going to be the advanced version of this searching algorithm. Thank you.